Hello everyone, my name is Ruksar, and from today onwards I will be uploading a video on a weekly basis, and this is particularly to help you to sit for your O-level examination for your maths paper. So today we will start off with the grade 10 first chapter, which is the perimeter. So when you talk about perimeter, you know a lot of this is something that you've been learning from your smaller grades itself. So find the perimeter of a square, find the perimeter of a triangle, very common things that you've already worked on. So let me just take you through a recap of what you may be already knowing. But when you want to find, let's say you have a square and you need to find the perimeter of this square. When you talk about the perimeter, which means it's adding all the sides. So all four sides need to be added. And let's say if this was 6 centimeters. So you have two ways that you can find the answer to this. Either you multiply 6 by 4 because there are 4 sides, so that will give you 24 centimeters, or you can add 6 4 times, which means 6 plus 6 plus 6 plus 6, which also gives you the answer 24 centimeters. Remember, we need to put the units as centimeters when we are centimeters, meters, just that one unit, no squared, nothing, when we talk about the perimeter. With that, let me move to another example. If you have to find the perimeter of a triangle, so we can draw any triangle over here. So I'm just drawing a triangle. There we go. So let's say we have the sides. This is going to be 4 centimeters, and this is somewhere around 6 centimeters, and this is 8. So if you have something like this, to find the perimeter, like I told you, you need to add all the sides. So that's going to be 6, or 4 plus 6, 4 plus 6 plus 8. So which means 4 plus 6 is equal to 10, and 10 plus 8 is 18. So the answer would be 18 centimeters. And now let's say, focusing on this lesson itself, which is related to perimeters of a sector. So before we move on to the sector, let's see how to find the perimeter or the circumference of a circle. So when we talk about the circle, we really don't say perimeter of a circle, we say circumference of a circle. So to find the circumference of a circle, the equation is 2 pi r. So you might have heard of this in your grade 9 class, where you have the equation 2 pi r. And when you talk about pi, pi can be 22 over 7 in fraction, or it can be 3.14 in decimal. You can use either 22 over 7 or 3.4 depending on the question, which is easier. That's a choice that you make there, right? So when you're finding, let's say for example, you have the radius, which is 7 centimeters. So when you talk about 2 pi r, you need the radius. So radius is 7 centimeters. How would you find the circumference here? 2 pi r, so 2 times 22 over 7. So I'm going to put that in here, 22 over 7 multiplied by the radius, which is 7. So when we talk about the radius itself, when we talk about this question here, we can actually simplify the 7 and the 7 because they're both like numerators and denominators, and it's multiplication. So we can just cut it off, and 2 times 22 would give me 44 centimeters. So that will be to find the circumference of this particular circle. But let's say we have a sector that has been formed. Now, what is exactly a sector? So if you talk about a slice of pizza, that is a sector because you're taking a part of it, right? So if you talk about this sector, there is an angle that has been formed here. Now that angle will be labeled as theta, or you can say x, y, whatever you prefer, but usually angles go with the value theta there, the variable there, so theta. And another thing that you need to remember is about the angle around a point. So angle around this point, like entire circle that you form there, would be 360 degrees. So that is the exact reason why we have to look into 360 degrees. So if you need to find the perimeter, or the first thing that you need to do is to find the arc length, that is this particular part, because perimeter is basically adding all the boundaries. So we have this boundaries according to the previous example. We know that this is the radii, and both of them are the radii here. So this is going to be 7 and 7, which we already know. But the problem that comes in is to find this particular part here, the arc length. So to find the arc length, we can use theta over 360 multiplied by 2 pi r. So I'm going to write that as 360 multiplied by 2 pi r, which is going to be 2 times 22 over 7, and then multiply by the radius itself. So if I want, I can give an angle to this. So say that this is 60 over 360 and then simplify this question. So this is like the basics of this lesson itself, the lesson of perimeter. So now let's look into the textbook and see what we have in store for us there. So let me quickly share the textbook with you there. So here we go. So I think we pretty much covered some things over here, how to find the perimeter of the square in a triangle, and then we did cover about how to find the perimeter of the circle, or the circumference of a circle, in other words. And we did work around this equation as well, which we have here, theta over 360 multiplied by 2 pi r, which is the arc length. So this is an example that they've worked around, where they've given us that the angle is 45 degrees and we need to find 45 degrees over 360. And yeah, before we go to that example itself, if you look at this part over here, they've explained us how much 180 over 360, which is a half, like a semicircle, can be written. Instead of writing 180 over 360, you can write half times 2 pi r as well, if you want to find the arc length of this particular part. And if you move to this quarter circle, this is 90 over 360, the angle here is 90 over 360. You know that you can cancel off the zeros, that is dividing both the numerator and the denominator by 10. And then you have 9 over 36, so 9, you divide both 9 and 36 by 9. So 9 times 9 divided by 9 is 1, and 36 divided by 9 will give you 4, like 9, 18, 27, 36. So likewise, you have for 120 and 270 as well. 270 over 36, you can see you can cut off the zeros because they're divisible by 10. And now you have 27 and 36. So 27 and 36, it comes in the 9 times table once again. So 9, 18, 27, 36. So 9 times 3 is 27, and 9 times 4 is 36. So that's how you get 3/4. So moving to the example that we have over here. So it's 45 over 360. By looking at this, you know that 45 is not divisible by 10. But instead it is divisible by 5, because you can look at the digit, the last, or the ones here, and if the ones are a 0 or a 5, you know that it's divisible by 5, right? So you know that you can divide 45 by 5 and 360 by 5 as well. So 45 divided by 5 would give you the answer 9. And if you look at 360 divided by 5, now how do we divide this without using the bus stop method itself? So you can look at the question. 3 you can't divide by 5, so let's go to the next part, which makes it 36. So 5 times 7 would give me 35. So I'm going to write 7 here and 35, but it's 36, so I have one remainder, which gives me 10. So 5 times 2 is 10, so I have 72. So 9 and 72, you've got to know your tables really well to do this, and this is like one of the easy methods that you can use. So 9 and 72, 9 times, or divide both of them by 9. 9 divided by 9 is 1. 72 divided by 9 will give you 8. So that will give you 1/8. And now you're finding the arc length. So 1 over 8 times 2 pi r, 2 times 22 over 7 times 7. So you see a lot of like a cut and chop done over here, and what exactly does that mean? So you see that when it's multiplication, and when you have the 7 and this 7, you can cancel them off, the denominator and the whole number that they've given here, because this is basically 7 over 1. So you can cancel the numerator and the denominator there. And apart from that, what they've done is they've cancelled 2. They've divided 8 and 2 by 2. So 2 times 1 is 2, and 2 times 4 is 8. Likewise, they've moved on to 22 and 4. So 22 is divisible by 2, 4 is divisible by 2. So they've divided this by 2. 4 divided by 2 is 2, and 22 divided by 2 is 11. So we remain with 11 over 2. So neither of them are divisible by 2. So you divide, actually you do go to the bus stop method, or whatever you prefer there, and divide 11 by 2, which gives you the answer 5.5 centimeters. So this, remember, is the arc length, and not the final answer if they ask you to find the perimeter. So if they would have asked you to find the perimeter, now arc length is this particular part. This is what is 5.5. Yeah, this is 5.5. So this is 7 and this is 7. So if they would have asked a question to find the perimeter, this would change to perimeter equals 5.5, add 7 and add another 7 because we have two radius here. So 7 add 7 is 14, 14 add 5.5 would give me a 19.5 there. So 19.5 centimeters. And then that's like the example that we've used there. And let me clear the screen to move to the second example. Now in the second example there's a small twist to it where they've given us the arc length, which is 44. So basically they've given us that this particular part is 44 and we need to find the radii or the radius, which is not given. So according to our equation, we know that theta over 360 multiplied by 2 pi r gives us 44. So theta is 120, so 120 over 360 multiplied by 2 pi r is equal to 44. So they've equated it first. Now the first thing that we need to see is what are the things that I can simplify here. I replace it. I replace, like, pi with 22 over 7. I replace the r but I don't know the r, so I leave it as it is. And then now I try to simplify 120 and 360. I try to cut off things there. So let's see how we can simplify 120 and 360. If you look at that part there, you have 0 and 0, which can be cancelled off because they're divisible by 10. So 0, 0 gone. And 12 and 36. So 12, 24, 36. 12 in the 12 times table, you have 36. So 12 times 1 is 12 and 12 times 3 is 36. So this becomes 1 over 3. So now what exactly do we have? We have 1 over 3 times 2 times 22 over 7 times r. So I'm just going to write that in there. 44 is equal to 1 over 3. So 1 over 3. It's just a little bit here and there, but yeah, 1 over 3 times 2 times 22 over 7, and that's multiplied by r. So this is what we have exactly to say. So I'm just going to draw the fraction bars to get a clearer picture there. Now we need to see how am I going to subject r, like leave the r alone and take the rest away. So all the denominators here would become the numerator when they move to the other side. It's like the inverse. The division becomes the multiplication. So when you talk about the fraction bar, actually the denominator means divided. 22 is divided by 7. 1 is divided by 3. So we take it to the other side and we make it multiplication. So it becomes over here 44 times 3 times 7. If you really want, you can multiply 3 by 7, get 21 and take it like 44 multiplied by 21 instead. That's also an option, but it's easier to leave the numbers as simple as possible. And now we have, we talk about the numbers here, 2 and 22 and 1. What happens there? So 2 times 22 is 44 r, which means 44 is multiplied to r. So when you take 44 to the other side, it has to become the denominator. The opposite happens. So this becomes the denominator. In this also you can leave it as 44 if you want, like 2 times 22 is 44, or if you want you can leave it as 2 times 22 itself. So this is what happens, and now we have on this side we have equals r, which is the radius all alone. So we've subjected r. So now moving to the next part, what needs to be done here is the simplification. We need to simplify. So we know 2 times 22 is 44. So basically this entire thing gets cancelled off, and 3 times 7 is 21. So that gives us the answer that r, or 21 centimeters, equals r, or we can write that as r equals 21 centimeters. Either way it's equal there. So r equals 21 centimeters. That's how we find the radius of a sector when the arc length is given. So let me clear this part, and then based on that, this is another example that they've worked where they've given us to find the angle where the radius and the arc length is given. It's the same procedure, but just that we are subjecting theta here. So it becomes 11 times, all the denominators become the numerator. So 11 multiplied by 360 multiplied by 7 divided by 2 times 22 times 9, and then you do the simplifying and you get the answer for your theta there itself. So that's like, based on that, you have the exercise 1.1 where they say find the arc length of the sectors given below. And just to give you an insight there, when it comes to questions like this, here they've given us 60, but remember this angle is outside the circle. So if you're finding the arc length, you need to find this part. So basically you need to find this angle, which is going to be 300, because the entire angle is 360. So 360 minus 60 is 300. So let's not forget that part. And then moving to, like, finding the perimeter, and this exercise wherever they tell you to find the perimeter, remember you need to add in the radius, both the radius. So remember that's what they've done. They've added 2 times 21 here to make it 86 centimeters. And they've given us a few questions where you need to find the radius where the perimeter is given. And so let us just work one more question under this, and then I think we will be done with the chapter itself. So here they're talking about the perimeter of a sector, which is 2/3 of a circle, and is 260 centimeters. Remember, when they say 2/3 of a circle, they've actually simplified whatever it was, like, theta over 360 has been simplified, and you've got 2 over 3. So basically it can be like, 1 over 2, 240 over 360. So 240 over 360 can be divided, and you get 2 over 3 there as well. And then that is 260. You can just use this fraction that they've given itself. So when you look at this, how do you work it out? Like, arc length is 2 pi r times 2/3. So 2 times 2 is 4, and then you have to replace the pi with 22 over 7. So when you see that, you multiply all the numerators. 22 times 2 is 44. 44 times 2 is 88, and 7 times 3 is 21. So 88 over 21, 88 r over 21. That's the arc length, but we do not know what the radius is. And to find the perimeter, you have to add the 2 radius, like I told. That's what they've put, 2r. So now our equation is 88 over 21r, or 88r over 21 plus 2r equals 260. Now we need to figure out what we need to do to subject r. Remember, we can't just add 88 plus 2r and say that, okay, 88 plus 2 is 89, 90, so 90r. You can't do that, because here the denominator is 1. This is a whole number and this is a fraction. You can't just add the whole number with the numerator itself. So for that, what you need to do is actually find the LCM of 21 and 1, which is 21 itself. So this is 2r over 1. So you multiply this denominator by 21, which means 2r is also multiplied by 21. So now 21 times 2 is 42r. So now what happens is the equation changes to 88r plus 42r, and you have a common denominator, which is 21, because you found the LCM to get that answer. So this is what you have over here, which is equal to 260. Right? So that's according to the question that they've given. Now we can add 88r and 42r because they have a common denominator. Now there's no problem in adding them together. So that becomes 130r, 130r, and 21, which is divided, we take it to the other side and we multiply. So 130r is equal to 260 multiplied by 21. So when you do that multiplication, or you can simplify r, because 130r means 130r is 130 multiplied to r. So we can divide it. R equals 260 times 21 divided by 130. Okay, now let's draw the line there and then see how we can simplify this. So 0 and 0, because both of them are divisible by 10. Remember, this can be done only if this is a multiplication. If this was an addition, no, you can't do that. That's not the way you simplify. And then 13 times 1 is 13. 13 times 2 is 26. So you can multiply 2 by 21 and get the answer. R equals 42 centimeters. So that's basically how you work out a question when you have have a question where the perimeter is given and not the arc length. So moving to the exercises here, they have a few questions where you need to find the angle and the perimeter. And here they have some compound figures where you have to find the arc length, that is this particular part, and add 20 plus 20 plus 14. Remember, this particular line will not be added because that's not the boundary. That's inside the diagram and not at the boundary level. So that will not be added there. And apart from that, some diagrams you might have like some compound figures like this, where they are asking us, like, they might give you a square, they have given you a shaded part, and they're asking you to find the perimeter or the circumference of this remaining part. So for that, you will have to find the arc length, this part and this part. That can be found using the Pythagoras theorem. We will do in details, like, how to work around Pythagoras theorem as well in another class. And then you can just do the subtractions there, and or find out what value this is, find out what value this is, and add this part 15, this part, this whatever you found, and this the arc length that you've found. So that's pretty much it from this chapter. And if you do have any questions regarding any of the exercises or anything else, do drop a comment, or you can also send an email. So thank you very much for joining in. Have a nice day. Bye.